In this lesson, we're going to work on adding and subtracting fractions when their denominators are different. Of course, that's the primary objective for the lesson, but we're also going to see how to visually represent adding of our fraction. That's more just for a knowledge base and not so much a skill that you're expected to have. But we also want you to be able to find the total length when you have to add up fractional lengths. Now, there are a few skills that you will have to start with this. We expect that you can already multiply whole numbers. We expect that you can add and subtract fractions when the denominators are already the same. And you also need to be able to simplify fractions by identifying what their common factor is and dividing it out. Now, some basic things that help out with the visual. One of the problems that we have when we were adding fractions, if we wanted to add 2/3, we'd be able to shade in 2 out of the 3 boxes. And if we added it into 1 out of 4, we'd be able to look at it and say, okay, there's 1 out of 4 pieces. One of the common things that students try to do is they look at the fraction and they think, well, I can just go straight across the top. 2 plus 1 to get 3, 3 plus 4 to get 7. A lot of times students try to do this. And what we wind up seeing then is visually, that's like saying we've got these 2 blocks, 2 out of 3, plus 1 out of 4. And then when we start shading these things in, we'd say 1, 2, 3, 4, 5, 6, to create 7 blocks that are all the same. Well, if we shaded in 3 of those, does it look like we can combine each of these other 3 blocks and have it be the same area?
Yes.
That's not going to work that way. And we can see it a little bit better visually if we grab these ones and say, all right, there's 2/3, here's a quarter, and if we put those 2 pieces over here, is that the same? The black with the yellow?
No.
Clearly not. And this is the problem where students try to go straight across. You wind up saying things like the shaded area in the black is the same as the yellow, and it's clearly not true. So how do we wind up fixing that? Well, when we wipe the slate clean, the main issue that we're actually running into is that the blocks were different sizes. We saw before that if we want to add and subtract fractions when the denominators are the same, it's based on having blocks that are the same size. In particular, we could take this one block and have our 2/3, have our 1/4, and if we want to add them together, the only thing we can do is have blocks that are the same size. And again, I want to emphasize, this is not a skill that we expect you to be able to draw out. We're putting it in just for background information so that you'd have a better understanding of the techniques when you get into them. But what you would need to do then is split these pieces up so that they're smaller chunks. And this is one that I can split that up into 4 pieces, another 4 pieces, and I'm going through kind of quickly, so it's not going to be entirely clean and beautiful. But we can split this up so that there are 12 chunks. What that's actually doing for us is taking and changing it from 3 blocks into 12 by chopping them up each of the big blocks into 4 pieces each. Likewise, when we had this shaded region with 4 of them, that's 1, 2, 3, 4 blocks, 5, 6, 7, 8, we were also splitting those up. By multiplying this way, we were able to create the fraction 8 out of 12. We have a similar technique or the same issue going on over here. We could split these pieces up into smaller chunks and then observe we took this block that was originally this wide and we chopped it up into 1, 2, 3 pieces. So we'd multiply by 3 to create the same size, allowing us to get the fraction 3/12. Now that we have a common denominator, we can actually combine them. This would wind up being 8 pieces plus 3 pieces out of the total of 12. And we'll note here, 1, 2, 3, 4. Wow, this is really sloppy. But we're getting the idea for them. Split them up. And what we wind up seeing then, we could shade in 11 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And just to elaborate further, going back to that visual that we had. Oh, I wanted that filled in. We could take these two pieces, and when we add them together, we'd see it's actually is matching up to what we have. Finally, 8 plus 3 would give us 11 out of 12. What all this indicates for us, it's based on the observation that when we need to get these common number of blocks, that's the common denominator. The only way you can add fractions is when the denominators are the same. And so we started off by looking at this and saying, with a denominator of 3 and a denominator of 4, we had to have a way of making them the same. We were looking basically for a least common multiple. Well, a lot of times students struggle with identifying what the least common multiple is. And I'm sure you had teachers go through and show you before that if you recognize the least common multiple is 12, then you would have to multiply by 4 to turn the 3 into 12. You would have to multiply by a 3 to turn 4 into 12. Well, I'm going to show you a different way of writing it up. And this particular method is both good and bad because it's a very simple, straightforward rule. If you remember this picture, it tells you exactly what you need to do to get the answer. Really straightforward, really direct. This will work on every single adding and subtracting problem there is. If you need to add or subtract fractions, this is going to work. It will work when the denominators are the same. It will work when the denominators are different. The one downside to it, though, it tends to create some bigger numbers, so a lot of times you need to simplify at the end. It's really, really common to have to simplify. It's basically just 3 pieces. Multiply those two numbers. 7 times 2 gives you 14. Then you multiply the other diagonal. 1 times 5 is 5. Because this was an adding problem, we're going to keep it adding. And the third part, to finish off our picture, is to go straight across the bottom. 5 times 7, that's 35. And you'll note, just these 3 quick pieces of multiplication created an answer that has the same type of structure as what we had right there. But it's less work to get to that. Now we just have to actually do the number crunching. 14 plus 5, that equals 19. 19 over 35 is our answer. We're done. And this will work for any time you need to add or subtract. 2 times 5, 1 times 9. Because it was a subtraction problem, it stays subtraction. Right across the bottom, 9 times 5. And so we've got our answer then. 10 minus 9 equals 1. Our answer is 1 over 45. We're done. Let's do a couple more examples. 1 times 3. 2 times 5. 5 times 3. And so when we continue, 3 plus 10 equals 13. And we have our answer, 13 over 15. So far, none of our examples have required us to simplify at the end. I wanted to pick a couple of problems where we didn't need to simplify just so that you could see the process. However, when you use this technique, it is really, really common that you will have to simplify at the end. 1 times 4. 1 times 2. 2 times 4. And so here's our answer. 2 plus 4 equals 6 over 8. This is a classic example of, in the end, we have a correct answer, 6 out of 8, but it is not simplified, so we do have to recognize what number can go into both 6 and 8, divide out by their common factor of 2, and get the simplified answer of 3/4. Same thing here, 1/3 minus 1/4. 1 times 4. 1 times 3. 3 times 4. 4 subtract 3 equals 1. And we have our answer, 1/12. We're done. That won't simplify. 3/5 and 3/7 minus 2/5. 3 times 5 is 15. 2 times 7 equals 14. 7 times 5 equals 35. And we've got 15 subtract 14 equals 1. Our answer is 1/35. Done. Last problem that we have, adding fractions is really, really common when you need to work with distances. For instance here, you run 3/8 of a mile to the store. Okay, so from your current place, from your house, you went to the store. That was 3/8. From the store, you ran to the school, which was 1/6. Well, notice if you take two paths together, this is saying take 3/8 of a mile and then another 1/6. It's really common to need to add fractions when you're talking about adding distances. Fortunately, we can go through and do all our number crunching. 3 times 6 equals 18. 1 times 8 equals 8. 8 times 6, that's 48. When we add those together, 18 plus 8 on top gives us 26. And in our denominator, we have 48. That's our answer, 26/48. This is one, though, that will simplify. If we divide out by their common factor of 2, this will give us 13 over 24. And does that simplify further? No, 13 is a prime number, so 13 prime, it doesn't go into 26. We would finish it off right there. We ran a total of 13/24 of a mile. We're done.